Alright folks, it's Bass Action back in action here. In this video, we're going to be on the back of the pink foldable and we're going to go through all the various triangle inequality properties, okay? There are quite a few of them on this page and you're probably going to want to reference this video later, particularly on example 3 in this first column. Alright, our most basic triangle inequality is called the side angle inequality theorem. And this is often, in a simplified terms, is referred to as big side, and we're going to put a double-ended arrow here, big angle, okay? And what it's basically saying is the biggest side in a triangle will be across from the biggest angle, and vice versa. The biggest angle will be across from the biggest side. So the two most basic forms of this question are what we have here on example 1 and example 2 here. So for example, it might say list the angles from least to greatest, and you do want to be really careful to read this order because we do flip it around. Sometimes it's small to big and sometimes it's big to small. So if we want to go from least to greatest, what we're going to do is we're going to find the smallest side in this triangle, and that would be the 8, and then the angle then, the smallest angle would be across from angle 8, so it would be angle P. Now, I often like to find the biggest one next, okay? Sometimes I think that's a little easier. The biggest side in the triangle would be the 15, so the biggest angle would be angle A. And then, of course, the only remaining angle in the triangle would be angle S. Okay, so that would be our angles, or our angles from least to greatest. Then we want to do sides. So on the next one, if we want to do sides, this time we're going to go big to small. We're going to do greatest to least. Notice on this triangle that we have not filled in that last angle. Well, since we know all the angles add up to 180, we could easily fill in that last angle by subtracting, and we would get 97. Now, if we want to find the biggest side first, we're going to find our biggest angle. We can now see it's the 97. So the biggest angle is angle G. Go across. That makes the biggest side, side UT. Okay. And then if we want to, again, I like to sometimes do then the smallest. The smallest angle is 31, which makes the smallest side UG, which makes the remaining side that's left, TG, the one in the middle, okay? Now, we could put bars if we're just naming them, but if we're saying we're listing their measurements, we would not put the bars. I don't get particularly picky about that part. Now, this next problem, we're going to do two examples like this. This next problem is definitely more difficult for students. The important thing to notice in this instruction is that it's asking for us to find the largest segment, particularly in the figure. The big angle, big side theorem that we just went through in the previous two examples only works in triangles. And when we look at this figure, we can see that this figure is not a triangle. We, in fact, have a quadrilateral here. I have drawn in the diagonal to create two separate triangles, but within this figure we have multiple triangles. So if we want to do this, what we're going to do is we're going to break this down and analyze the triangles separately. Now, what I like to do is I like to label the sides with just something simpler instead of having to use full segment names. So I'm going to, for example, name this side A, I'm going to name this side B, this side C, then I'm going to call this one D, and I'm going to call this one E. Then what I'm going to do is I'm going to finish off the angles in my triangles, and when I look at this triangle here on the top, I'm going to fill in this remaining angle right here as 60 degrees. And then when I look at the given information, I see that I've got some parallel lines. So remember, we can do our little Z, okay? So if this angle here is 60 and I follow the Z, then this angle right here is also going to be 60 degrees. And then I can fill in the last angle of this triangle BCD. That last angle is going to be 70 degrees. Now, that all the angles have been labeled, now I'm going to analyze each triangle separately. So I'm going to first look at this top triangle. That's just the one I chose to start with. It doesn't matter. And I'm going to list the sides in this triangle using the big side, big angle theorem, that triangle inequality, and I'm going to list them from small to big. So looking at this triangle, the smallest side would be B, the largest side would be A, so my sides from small to big are going to be B, C, A. Now, when I write this as an inequality, it's sometimes easier to do it that way. I can see that B is smaller than C, which is smaller than A. Now I'm going to look at the second triangle, completely ignoring the first one. I'm going to list these sides from small to big. The smallest side in this triangle is actually A because it's across from the 50. So notice that A is the smallest side in the second triangle, but it's the biggest side in the first triangle. So A is going to be smaller than D, and that is going to be smaller than E. So in the second triangle, the largest side is E. Now, what I'm going to notice is that when I look at these two inequalities, side A is in both triangles. So its length doesn't change, but its relationship does. So when I connect all these inequalities mathematically, I can see that B is smaller than C is smaller than A, which comes to here, which is smaller than D, which is smaller than E. So I can see that E is the largest side in the figure. So when I look at my picture, I can see that that's BD. So BD is the largest. Now this particular problem would also allow me, squeezing my R there, would also allow me to find the smallest. If it did ask for the smallest, we could identify that as B. Now we're going to do this one more time, just so you can see one more example. Again, it's often easier if you name those sides first. So I'm going to call them A, I'm going to put a B, I'm going to put a C, a D, and an E. That's just how I chose to do it. I'm going to choose to start with this. Oh, I'm going to fill in my angles first, sorry. This remaining angle right here is 45 degrees. You might need to pause. I've obviously done the math before I started the video. And this one will be 50 when you check those. Now, when I list the angles on this triangle on the left from small to big using big side, big angle, I'm going to get B is smaller than A is smaller than C. And then in the second triangle, using big side, big angle, I am going to get that C is smaller than D is smaller than E. And then I'm going to connect them again by the side that they have in common. So my largest side in this figure, again, is going to be E. That's just a coincidence with how I happened to name them. So on this one, E is side MN, so we're going to say that MN is the largest. Okay, now I'm going to end this video and I'm going to make a separate video for the next column where we're going to look at a little bit more of our triangle inequalities.